The domain of national air defense is fundamentally an exercise in applied engineering, pushing the boundaries of electromagnetic propulsion and guidance material science. For India, the development of an indigenous long-range surface-to-air missile SAM system, internally known as Project Kusha and often referred to as the Extended Range Air Defense System or XR-SAM, represents a monumental leap in sovereign defense capability. This is not a merely equivalent of S-400. It's bespoke engineering solution tailored to India's unique threat spectrum and strategic objectives. The success of Project Kusha is intrinsically linked to its symbiotic collaboration between Defense Research and Development Organization and Bharat Electronics Limited. As the apex defense agency, DRDO is the primary design authority for Project Kusha. Their mandate encompasses optimizing missile profile for high G maneuver, reduced drag and enhanced terminal accuracy. This involves advanced CFD modeling and wind tunnel testing, developing multi-stage solid propulsion rocket motors for initial boost and potentially liquid or hybrid propulsion for sustained flight, ensuring optimal thrust to weight ratio and burn characteristics for achieving extended range and high velocity, integrating inertial navigation systems with high accuracy ring laser gyros or fiber optic gyros complemented by GPS navic augmentation for mid-course correction. DRDO is an engineering advanced radar homing seeker and terminal guidance. These seekers will likely operate in X-band or Ku band, employing sophisticated digital signal processing for target discrimination, electronic countermeasure robustness, and multi-target engagement capability. The development of wide band low probability intercept (LPI) seekers will be critical engineering challenge. Developing high explosive fragmentation warhead with advanced proximity fuse mechanism. This involves optimizing fragments including low RCS platforms, ensuring secure high bandwidth communication between the ground-based control elements and the interceptor missiles. This required robust course correction, coding and anti-jamming protocols. Bharat Electronics Limited contribution is pivotal, particularly in the realm of ground-based sensor and command and control C2 elements, and acknowledged by Bharat Electronics Limited Chairman and Managing Director Manoj Jain. Their focus is on BEL is developing and manufacturing critical long-range surveillance and fire control radars. These will undoubtedly be active electronically scanned array radars, leveraging gallium nitride technology for increased power efficiency, broader bandwidth, enhanced detection range, and superior angle resolution. The challenge lies in integrating advanced beam forming algorithm, adapting knowledge for jamming suppression, and sophisticated target classification capabilities. This includes operating in L-band and S-band for initial detection and tracking of wide array of aerial threats, including stealth platforms, operating in X-band and C-band for high precision tracking, target illumination, if semi-active homing is an option, and missile guidance. These radars must handle multiple simultaneous engagement. Designing and integrating the integrated network infrastructure, human-machine interface, and real-time processing capabilities for the system battle management unit. This involves fusing data for multiple sensors, threat assessment, target prioritization, and launch authorization. Integrating defensive and offensive electronic warfare capabilities into ground segment to protect against enemy jamming and potentially disrupt enemy command control, communication, computer intelligence, and surveillance and reconnaissance networks. Beyond component manufacturing, Bharat Electronics Limited deep expertise in integrating complex electronic systems positions them as crucial partner for overall system integration and assembly of ground-based elements. This involves rigorous testing and validation of subsystem interoperability. Project Kusha interceptor philosophy is based on layered defense, necessitating different missile variants optimized for specific engagement geometries and threat profiles. The stated range M1 up to 150 km, M2 up to 250 km, M3 350 to 400 km. Distant engineering challenge. The M3 variant targeting 350 to 400 km will require significant advanced propulsion technology like incorporating multi-pulse solid rocket motor or potentially a ramjet boosted configuration for sustained high speed flight at extended range. Efficient propellant formation and nozzle designs are critical. All interceptors, particularly the longer ranges ones, are expected to achieve very high terminal velocity, likely Mach 5 plus, maintaining aerodynamic control at these speeds necessitates robot control actuation and advanced flight control algorithm that can operate effectively in varying atmospheric densities and extreme heat. The compact dimension of this interceptor demand extreme miniaturization of electronics while ensuring robust hardening against G-force, vibration and thermal stress during launch and flight. The system's ability to discriminate between actual target and decoy or traps will rely heavily on advanced signal processing in the ARS seekers and sophisticated algorithm in ground control station. This is particularly challenging against steel target and swarm attacks. While fragmentation warhead are standard, the possibility of dedicated kill vehicle or ballistic missile defense implies the need for precise kinetic energy intercept capability, demanding even higher levels of guidance accuracy and terminal maneuverability. The projected timeline of prototype completion within 12 to 18 months and user trial extending 12 to 36 months reflect inherent complexity of integrating these advanced subsystems. Key engineering considerations during the phase will include developing comprehensive test protocol to validate system performance during a spectrum of simulated and live aerial targets, including drone, cruise missile, fighter jets, and ballistic missile surrogates. This requires sophisticated telemetry, instrumentation, and data analysis. Seamless communication and data exchange with Indian Air Force integrated air command and control system is paramount. This demands standardized data formats, secured in-network protocols, and robust error handling to ensure a unified air picture and coordinated response. The system will likely be truck-mounted for tactical mobility, requiring robust suspension system, power generation unit, and environmental control for operations in diverse terrains and climatic conditions. Design consideration for each maintenance, modularity, quick component replacement, and a sustainable logistic chain for spare parts and technical support throughout the system's lifecycle. Project Kusha is not merely a defense acquisition, it is a profound engineering undertaking. It represents synthesis of cutting-edge aerospace electronics, software engineering. Its successful realization will not only provide India with an impenetrable indigenous air defense shield, but also validate its capabilities as significant player in global defense technology ecosystem, truly embodying the spirit of Atmanirbhar Bharat.